For this we make cases. So what we'll do is we'll take case 1 when from E1 we select 2 and 3, that is S1 is the set 3. Then case 2, S1 is the set 1, 3, and case 3, S1 is the set 1, 2. Okay, then proceeding, we have E1 corresponding to each of these. E2 is E1 minus S1, that gives me E2 is 1, it's 2 here and it's 3 here. F2 is F1 union S1, so F2 will be 1, 2, 3, 4. Here it will be 1, 3 and 4. Here again it will be 1, 2, 3 and 4. Recall that sets do not have repetition. And from the set F2, let S2 denote the set of the chosen elements. So we choose 2 elements from each of these F2s as well. Then G2 is G1 union S2. Finally 2 elements are chosen at random without replacement from the set G2. When that E1 equals to E3. So if E1 is equals to E3, that means we will make subcases here as well. From the set so here we can have the set of chosen elements as 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. What I'll do is take these here, take these here, and these here. Because these cases would be the same for these two, 2, 4 and 3, 4, and here the cases will be 1, 3, 1, 4 and 3, 4. These are all the possible, these are S2. Then G2 is G1 union S2. So here G1 will be 1 to 5. In fact, here for each of these, this is G1 or G2. For these, G2 will be 2, 3, 4 and 5. Here for these two, G2 will be 1, 2, 3, 4, 5, and it will be 2, 3, 4 and 5. So now that we have all the cases, so we have to choose 2 elements from this, and those 2 elements So the probability of each of these events is 1 by 9. Oh, sorry, not 1 by 9, 1 by 3 into 1 by 6 is 1 by 18 for each of these. So now we want E1 should be E3. E3 is E2 union S3. So E2 union the elements chosen from G2. So if E2 is 1, then we need 2 and 3 from here. So that becomes 1 upon 5. C2 is 1 by 10. So that's the probability of choosing this. And after choosing this, choosing 2 and 3, so that we get E1, E3 as E2 union 2, 3. So 1, 2, 3, which would be E1. And plus choosing this, and after this plus coming to this one, and after that choosing 2 and 3 again. So that is this. Plus E2 is 1, so if we choose 2, 3, we can choose that from here as well. So that will be 1 by 18 into 1 by 6 plus 1 by 6. So that is 1.4 C2. So these are all the ways of getting E2, E1 equals to E3 if we choose case 1. This is from case 1. What our final answer would be? The probability of case 2 upon, or rather the probability of E1 being E3 if we approach from case 2 plus the total probability from case 1, case 2 and case 3. So we have P case 1, which is 1 by 60 plus 1 by 36. Now we move to case 2. So for case 2, again the probabilities of each of these will be 1 by 18. It is 1 by 18 times. We have 3 here, so we need to choose 1, 2. We cannot choose 1 and 2 from here. We can choose 1 and 2 from here only. It will be 1 by 10 plus 1 by 10 plus 1 by 10, which is the total probability from case 3, because there is no other way of choosing from G2 that we'll get E3 as 1, 2, 3, because 1 can come only from here. So case 3's probability becomes 1 by 60, and case 2 will be we want P of case 3 upon P case 1 plus case 2 plus case 3, not case 2. I spoke earlier, but anyways we'll find case 2. So here the probabilities of each of these would be 1 by 9 into 1 by 9, because 1 by 3 of choosing this as S1, and following this from 1, 3 from this set, choosing 1 by 3 is the probability of choosing each of these. So 1 by 9 into, so S1 is we have 2, so we have to choose 1 and 3. So from here we'll have to choose 1 and 3. So probability of that would be 1 upon 10 plus 1 upon 10, and if we land up here, we cannot choose 1 because there is no 1 in this set, so there won't be. So from this side the probability of E1 equals to E3 would be 0. So the probability of case 3 becomes 1, case 2 becomes 1 by 45. So our final answer would be 1 upon 60 upon 1 upon 60 plus 1 by 36. From this 1 by 60 is this, plus 1 by 45 from here. So which becomes 1 upon 1 plus 60 by 36 is 10 by 6. 60 by 45 is 4 by 3. This is 5 by 3. 5 by 3 plus 4 by 3 is 9 by 3, just 3. So this becomes 1 by 5. So the answer is 1 by 5. Option A. This was a nice question. So it was a bit lengthy and confusing, but just unique cases will be able to solve.